In January, the Model Context Protocol was a punchline. Developer forums were full of the same complaint: painful setup, enormous token overhead. Why would anyone burn tens of thousands of tokens on a protocol operation that a direct command line call does for a couple of hundred? 6 months later, enterprise adoption up 12-fold. The protocol donated to a vendor-neutral foundation backed by Amazon, Google, Microsoft, Salesforce, and Snowflake. Agent traffic passing half of all internet traffic for the first time in history, and MCP sitting underneath it as the connective tissue. The punchline became the plumbing. Both halves of that story are true, and understanding why is the fastest way to understand what MCP actually is now. And here's the reason this video needs the word "now" in its title. The protocol is moving under your feet. Days ago, as I make this, a new specification release candidate landed that deprecates features every tutorial from last year teaches as core. The transport that half the older guides describe was retired over a year ago. If you learned MCP from a blog post written in the early days, parts of what you know are already wrong. This series is the corrective, current spec, primary sources, and the architecture underneath that doesn't churn. Welcome to the MCP Blueprint, a new series from this channel and the natural sequel to the Claude Certified series, where the architect exams kept asking when to use MCP and we kept promising to go deeper. 3 parts. Today, part 1, what the protocol actually is, the architecture, the primitives, the lifecycle, the governance, the honest economics, and the traps in outdated tutorials. Part 2, building a server properly. Part 3, the security blueprint almost nobody teaches. Everything from the current specification and official documentation linked below. Let's begin at the real beginning, the problem. Chapter 2, the problem MCP solves, because a protocol only makes sense against the pain that produced it. Picture the world before. You have several AI applications, a chat assistant, a coding agent, an internal analytics bot, and several systems they need to reach: an issue tracker, a document store, a database, a calendar. Every connection is a custom integration, bespoke authentication, bespoke data formats, bespoke error handling. 4 applications times 6 systems is 24 integrations, each one written, tested, and maintained separately, and each new application or system multiplies the mess. Engineers call it the N times M problem, and it's the same disease that plagued hardware peripherals before universal connectors. It's worth pausing on the name itself because it's unusually honest. Model, context, protocol. The model is the consumer. Everything this protocol moves ultimately lands in a model's context window as text and structure the model can use. The context is the cargo, tools it may call, documents it may read, templates it may start from. And protocol is the promise, a versioned, negotiated, transport-agnostic contract, so the model's side and the system's side can evolve independently without breaking each other. Plenty of standards have aspirational names. This one is just a description. MCP's move is the classic one: put a standard in the middle. Each AI application implements the protocol once as a client. Each system exposes its capabilities once through a server. Now the arithmetic collapses from N times M custom bridges to N plus M standard implementations, and any compliant application can talk to any compliant server it's granted. That's why the USB-C analogy stuck: one connector shape, negotiated capabilities, and the ecosystem effect where every new server enriches every existing client. The analogy was cute in year 1. In year 2, with thousands of servers and every major vendor's client speaking the protocol, it's just an accurate description. Make it concrete with one Teams Tuesday. Before, the platform group wants their coding agent to read the issue tracker. Someone writes a connector, auth flow, pagination, retry logic, 2 weeks. Then the analytics bot needs the same tracker, different team, different language, second connector, second fortnight, drifting apart from the first with every patch. After, the tracker team publishes one MCP server once, the coding agent connects, the analytics bot connects. Next quarter's brand new application connects on day 1, discovers the available tools at runtime, and never files a ticket asking for documentation. The integration cost didn't just shrink, it moved to the right place. The team that owns the system paid once. Chapter 3, the architecture, 3 roles, and getting them straight prevents half the confusion downstream. The host is the application the human actually uses, the Claude app, Claude Code in a terminal, and IDE. It owns the user experience, the model access, and the security decisions. The client is a component inside the host, one per server connection, that speaks the protocol wire format and enforces control. And the server is the program that exposes capabilities from some system, files, tickets, databases, browsers. One host can run many clients, each client pins to one server. Servers can be local processes or remote services. On the wire, it's JSON RPC, requests that expect responses, notifications that don't, flowing in both directions because this is a genuinely bidirectional protocol, not a one-way tool calling convention. The server can send the client notifications when its capabilities change, and in the current stable spec, certain negotiated features even let servers initiate requests back through the client. Hold that thought, because what lives on which side of this line, and what just got deprecated there, is this video's most important correction. Picture a single concrete host to anchor the roles. Claude Code running in your terminal is the host. You've connected 3 servers, a local file system server, a local Git server, and your company's remote issue tracker server. Inside the host live 3 clients, one per connection, each maintaining its own session, its own negotiated capabilities, its own security posture. The file system client talks over a local pipe to a child process. The tracker client speaks HTTPS to a service across the network, and the host composes all of it into one conversation where the model can read a file, check a diff, and update a ticket in a single reasoning chain. 3 roles cleanly separated, and every debugging session starts by asking which of the 3 you're actually looking at. Chapter 4, What Servers Expose, 3 Primitives and the distinction between them is a design decision you'll make in Part 2, so learn it as intent, not just vocabulary. Tools are executable actions. Create a ticket, run a query, send a message. The model decides to call them, arguments validated against a declared schema, results returned into the conversation. Tools are the verb. Resources are read-only context, file contents, database records, documents, anything the application might load into the model's context. No side effects, standardized listing and reading, and in the current spec, resources can even carry icons and be linked directly from tool results. Resources are the noun, and prompts are reusable templates the server publishes, parameterized version starting points for common operations, chosen by the user rather than the model, surfaced as /commands or menu entries in a host. Prompts are the script. Verb, noun, script, 3 primitives, each with standardized list and fetch operations, and each discoverable at runtime, which is where the lifecycle comes in. Zoom into a tool's anatomy for a moment, because Part 2 lives here. A tool declares a name, a description, and an input schema, the types, the required fields, the constraints. The model reads the description to decide when to call it, and the schema to know how. Which means the description is doing selection work, and the third law from the certification series applies verbatim. Tool descriptions are the number 1 lever. A weak description with a perfect implementation misfires constantly. A strong description, what it does, what input it expects, example queries, explicit boundaries against similar tools, makes even a modest implementation reliable. The spec can only carry the contract. The craft is in the words, and it's coming in Part 2. And the design test for the tool versus resource boundary, since it decides real architectures, does it do something or does it provide something? Fetching a document, resource. Searching documents by query, that's computation with parameters, a tool. Reading a ticket, arguably either, and the tiebreaker is who initiates and whether arguments are needed. Model initiated with arguments leans tool, application loaded context leans resource. Get this boundary wrong and nothing crashes, but your server becomes confusing to hosts and models alike, and confusing servers get their tools miselected. Design intent first, primitive second. Chapter 5, the client side and the single most common error in the entire MCP tutorial ecosystem. The specification also defines capabilities offered by the client to servers. Routes, the client tells a server which directories or locations it may operate in, an operational boundary. Sampling, a server may ask the client's model to generate a completion, under user control and policy, without the server holding model credentials. Elicitation. A server may ask the client to collect additional input from the user mid-operation. Notice the direction. These are things the client provides that servers request. Assigning them to the server side is the recurring mistake in tutorial after tutorial, and if you hear someone describe building sampling into their server as a server feature, you've found a guide that never read the spec. And now the twist that makes this chapter genuinely current. In the release candidate published just days ago, 2 of those 3 client features, routes and sampling, are deprecated, alongside protocol-level logging. They remain in the specification through a deprecation window, but the official guidance for new implementations points elsewhere. Pass what routes conveyed as explicit tool parameters, let servers that need model access call provider APIs directly, and send diagnostics to standard error or OpenTelemetry. The lesson for a builder is bigger than the details. MCP is a young, actively governed protocol. Features can and do get retired, and the durable knowledge is the architecture and the negotiation model, not any single feature's existence. Which is exactly why the next chapter matters most. For completeness, what remains alive and well on the client side, elicitation survives, and the newest stable revision even extends it with a URL mode, letting a server hand the user a link to complete something, an authorization, a form in a proper browser context. So the durable client-side picture for new builds, elicitation for mid-operation user input, explicit tool parameters where routes once implied boundaries, and provider APIs where sampling once ran through the client. Learn the capability negotiation machinery, not the feature list, and revisions stop being scary. Chapter 6, the lifecycle, the part that doesn't churn, and the mental model that survives every spec revision. A session has 4 phases. Phase 1, transport establishment. The client opens a channel to the server. Phase 2, initialization. The client sends an initialized request carrying its protocol version and a capabilities object declaring what client features it supports. The server replies with its own version and capabilities, which primitives it offers, whether its lists can change dynamically, what it can do. This is capability negotiation, and it's the protocol's quiet masterpiece. Nothing is assumed, everything is declared, and neither side may invoke a feature the handshake didn't establish. Phase 3, operation. The client discovers what's available, listing tools, resources, prompts, and invokes as needed. The server answers and can notify the client when its offerings change, so a client learns about new tools without reconnecting. Versions, by the way, are date strings negotiated in that same handshake, which is why you'll hear spec revisions named like dates, because they are. Phase 4, shutdown, close the transport, no ceremony required. Establish, negotiate, operate, close. Every MCP interaction you will ever debug is somewhere in those 4 phases, and asking which phase am I in is the first diagnostic question, exactly the instinct the architect exams trained with lifecycle questions. Run the diagnostic once as a drill. Symptom, your brand new tool doesn't appear in the host. Which phase? If the server never launched, phase 1, transport, check the command path or the endpoint. If it launched but the host shows nothing at all, phase 2, initialization, check the capability declarations. A server that forgot to declare tools support has legally hidden them. If other tools show but not yours, phase 3, operation, check the tools list response and whether a list changed notification was needed. 4 phases, 3 checks, 90 seconds, and no guessing. That drill, generalized, is most of MCP debugging. Chapter 7, transports, and the second great tutorial trap. The current specification defines 2, standard I/O for local servers. The host launches the server as a child process and they speak over standard input and output. 0, network surface, brilliant for tools on your own machine, and it's how most desktop integrations run. And Streamable HTTP for remote servers, a single endpoint over HTTPS supporting streaming, multiple clients, and proper web authentication. That's the pair. The trap, an earlier remote transport, HTTP plus server send events as a 2-endpoint design, was deprecated back in March of the transport's 2nd year, over a year ago now, yet older tutorials still teach it as current. If a guide shows separate SSC and message endpoints, you're reading history. Modern remote MCP is Streamable HTTP, and Part 2 builds on exactly that. The choice between the two is mercifully clean. Same machine, personal or development use, no network exposure wanted. Standard I/O, and you inherit the operating system's process security for free. Multiple users, remote systems, production services, streamable HTTP, and you inherit the web's authentication machinery, which the spec now leans on properly, as the security chapter previews. The one wrinkle worth knowing early: local servers run with your permissions. Everything you can touch, they can touch, which is convenient right up until it's the audit finding. Hold that for part 3. Chapter 8: Who owns this thing? Because for enterprise adoption, that question was the blocker. MCP began inside Anthropic, announced in late 2024, and for its first year the fair objection was single vendor risk. Why standardize on one company's protocol? That objection died in December when the protocol was donated to the Linux Foundation under a new vendor-neutral body, the Agentic AI Foundation, with backing from Amazon Web Services, Google, Microsoft, Salesforce, and Snowflake. Then in March, an official public roadmap landed, and the enterprise data shows the response. The single sharpest adoption jump in the protocol's history, nearly tripling month over month in some ecosystems, precisely when governance stopped being a reason to wait. The machinery of evolution is public too. Changes move through a proposal process, and the newest release candidate formalizes extensions, optional, independently versioned additions with their own identifiers, negotiated in the same capability handshake, so the core spec stays small while the ecosystem experiments at the edges. The first official extensions are telling. One lets servers ship interactive interface components that hosts render in a sandboxed frame, declared ahead of time so hosts can review them before anything runs. Servers that render UI safely through negotiated capability. That's a protocol growing up in public with security review built into the growth. The version story in one breath because dates anchor trust. Late 2024, initial revision and public announcement. Mid-2025, a major revision adds structured tool output, elicitation, and resource links in tool results, classifies remote servers as OAuth resource servers with modern token binding requirements, and removes JSON RPC batching. Late 2025, the current stable revision adding identity discovery, incremental scoped consent, icon metadata, and that URL mode elicitation. And days ago, the release candidate with formal extensions, the interface components extension, and the deprecations we covered. Roughly 2 meaningful revisions a year, each documented in a changelog you can read in 10 minutes. For Builder, that cadence is the good news, fast enough to fix mistakes, slow enough to build on. Chapter 9, The Honest Economics, because this channel doesn't do religious wars, and the January critics were not wrong about the numbers. An MCP operation can carry real token overhead, tool catalogs, schemas, negotiation context, tens of thousands of tokens in heavy setups, where a direct command line invocation of the same underlying capability might cost a few hundred. For a token-efficient production pipeline doing one known thing at scale, a direct integration wins that comparison, clearly, and pretending otherwise helps nobody. So when does MCP earn its overhead? The architect examines protocol selection logic, now with real numbers behind it. MCP, when a capability should be standardized and shared, many applications, many teams, one server, discovery and authentication handled once, and every improvement propagating everywhere instantly. Direct API or command line, when one system talks to one service on a known path, and every token counts. Agent-to-agent protocols, when independent agents collaborate across organizational boundaries. And the emerging middle path the ecosystem converged on this year: progressive discovery, loading tool definitions as needed rather than front-loading entire catalogs, which attacks exactly the overhead the critics measured. The dial from the architect professional video, progressive versus monolithic context, is the live engineering debate of this protocol, and knowing which side of it your scenario sits on is the modern MCP skill. One worked example to make the judgment tangible: an internal document search capability, consumed by one nightly batch pipeline, direct integration, a few hundred tokens per call, done. Same capability consumed by the support desk assistant, the engineering co-pilot, the sales research agent, and whatever ships next quarter. Now the MCP server's overhead amortizes across every consumer. Discovery replaces 4 sets of integration docs. 1 authentication setup replaces 4 credential reviews. And the fair comparison isn't tokens per call anymore, it's total cost of ownership per year. Same capability, opposite verdicts, and the deciding variable was never the protocol. It was the number of consumers. Count consumers first, choose protocol second. Chapter 10, the adoption evidence, briefly, because claims about industry standards deserve numbers. Enterprise usage of major MCP deployments grew 12-fold across 6 months, with the March governance and roadmap moment producing the sharpest single jump. Token-based authentication, the machine-to-machine kind, grew from 1/7 of connections to nearly half in the same window, which is the signature of automated, agentic workflows moving from experiment to production. And on the host side, Claude and Claude Code together grew to roughly 40% of business MCP usage, which is worth knowing for a practical reason. The client you'll most often be building servers for is the one this channel has covered since the certification series. The trend lines and the governance arc point the same direction. This is infrastructure now. And the ecosystem you're joining. Official reference servers cover the everyday systems, file system, Git, databases, web fetch, maintained alongside the spec as living examples. Community servers number in the thousands, from issue trackers to design tools to home automation, discoverable through registries, which revives a law from the Architect Foundation's exam, now as ecosystem etiquette, check the community first. The server you're about to write probably exists. Your custom work belongs on the capabilities genuinely unique to your organization. Part 2 builds custom precisely because that's the skill, but the professional's first move is always the registry search. Chapter 11, Security, the preview, because Part 3 owns this territory and Part 1 owes you the shape of it. 3 facts to carry forward. First, the specification takes identity seriously. Remote servers are classified as OAuth resource servers, with modern requirements that bind tokens to the specific resource they are for, closing a whole family of token misuse attacks, and the newest revisions add discovery and incremental, scoped consent. Second, the architecture concentrates policy at the client and host. The client decides what servers may see and do, which is why the security conversation is mostly a client configuration conversation. And third, the one you already know from the Architect Professional video, the dominant real-world failure isn't cryptographic, it's permission sprawl, servers granted more capability than their role requires, the audit finding with a fresh acronym. Least privilege, capability hygiene, scoped consent, Part 3 in full. Why the client side carries the policy weight in one image. The server is a vendor at your door, the client is the one deciding which rooms it may enter. A server can offer anything, only the client's negotiated session, the host's configuration, and the user's consent turn offers into access. That's why MCP security reviews spend most of their time on host configuration, allowed servers, granted scopes, route boundaries, consent flows, and why the scariest deployments are the ones where nobody remembers what was granted. Inventory before cryptography. Part 3 starts exactly there. Chapter 12, 2 lenses in the house style. First, a tutorial you're reviewing says, quote, implement sampling in your MCP server so the server can generate summaries with its own model access. What's wrong? 4 options, nothing, that's standard. Sampling is a client capability that servers request, and it's deprecated in the newest release candidate besides. Sampling was removed from the protocol entirely years ago, or sampling requires the legacy SSE transport. The third overstates its deprecation with a window, not ancient removal. The fourth is word salad. The first is the tutorial's error repeated back. The second is exactly right on both counts, and knowing both halves, the direction of the capability and its current status, is what separates 2026 MCP knowledge from 2025 MCP knowledge. Second lens, the selection question. An internal pipeline calls one code search service from one batch job, millions of times monthly, latency and token budget both tight. The team proposes wrapping the service in an MCP server, quote, for standards compliance. Verdict. Options, correct, MCP is always the standard now. Wrong, MCP is deprecated for internal use. Right, instinct, wrong scenario, a direct integration wins here. and MCP earns its place when the capability is shared across many applications, or only correct if they also adopt agent-to-agent protocols. One consumer, one service, known path, tight budgets, the direct call wins, and standards compliance is not a business constraint, it's a costume. The protocol selection logic from the summit exam, working for a living. Third lens, transport identification, because it's a free point in any design review. A colleague's architecture diagram shows a remote MCP integration with two endpoints. One the client connects to for a server-sent event stream, and a second the client posts messages to. What do you tell them? Options looks correct, that's the remote transport. That's the deprecated two-endpoint design. Current remote MCP is streamable HTTP on a single endpoint. MCP doesn't support remote connections at all, or they should switch both endpoints to WebSockets. The third is false. The fourth invents a transport the spec doesn't define, and the first waves through a design retired over a year ago. The single endpoint correction is the answer, and diagrams like that one are exactly how legacy patterns survive. Nobody at the review knew the date on the tutorial the diagram came from. Now you do. Chapter 13, 5 Misconceptions, Rapid Fire, collected from a year of reviewing MCP content. 1. MCP is an anthropic product. It began there. It now lives in a vendor-neutral foundation with the industry's giants behind it, and treating it as one vendor's lock-in is exactly backwards. 2. Sampling and routes are server features. Client features requested by servers and freshly deprecated besides, you now know both halves. 3. The SSE transport is how remote MCP works. Retired over a year ago, streamable HTTP is the present. 4. MCP replaces APIs. It doesn't. It standardizes how AI applications consume capabilities, and underneath every good MCP server is usually a perfectly ordinary API doing the actual work. The protocol question is about the consumer count and the sharing model, never about replacing the plumbing that already works. And 5. MCP is a one-way tool calling convention. It's a bidirectional, negotiated version protocol with notifications, capability handshakes, and now extensions. The tool call is just its most visible move. 5 corrections, 30 seconds each, and you're ahead of most of the content written about this protocol. Chapter 14, Your Sources, free as always. The official specification site where the current stable revision and the release candidate notes live. Read the changelog pages, they're short and they're the truth. The official documentation and SDKs with quick starts for every major language. The reference server repository, real implementations of the patterns part 2 will teach. And the official blog where release candidates and roadmap updates land first. Everything linked below, and the standing rule of this channel applies double for a protocol this young. Check the date on any MCP content before trusting it, including, in a year, this video. And here's what part 2 builds so you can come ready. A real MCP server for a real capability in the current SDK over streamable HTTP. Tools with schemas that make the model's selection reliable, because tool descriptions are the #1 lever. The third law never left, resources with sensible boundaries, a prompt worth publishing, and capability declarations done honestly. Bring a machine with a recent runtime installed and 20 free minutes. Leave with a server your own Claude can call. That's the MCP Blueprint's next brick. That's part 1, the complete map, the problem and the collapse from n times m to n plus m. Hosts, clients and servers, tools, resources and prompts, the client capabilities and their fresh deprecations, the 4-phase lifecycle that outlives every revision. The 2 transports and the retired one still haunting old tutorials, vendor-neutral governance and the extension machinery, the honest token economics and when MCP genuinely earns its keep, and the security shape that part 3 will fill in. Independent content checked against the current specification, not affiliated with Anthropic or the Foundation, and built to be corrected by the primary sources the moment they move again. If the certification series taught you to pass the exams, this series teaches you to build the thing the exams kept asking about. Part 2, building the server, is next. Subscribe and it lands in your feed the day it ships, and if this cleared up something a year of blog posts muddled, a like tells the algorithm to show it to the next confused builder. We're building AI up from the ground, one blueprint at a time. I'll see you in part 2.